Hello students, I am Rohini Chowgle, one of your physics lecturer. Okay, already you know about classical mechanics and this is my third class. Okay, in previous classes what we discussed. Okay, in first class I explained about the basic things, what you mean by the classical mechanics, definition, etc. Okay, and second class the real syllabus means the definition of constraints, what to mean by the constraints and the examples of constraints, classification, etc. Okay, now tell me what you mean by the constraints. Okay, revision. First I will do the revision, just 5 minutes. Constraints means what? The restriction on the motion of a particle of a system, that is known as the constraints. Okay, the types are holonomic and non-holonomic, rheonomic and the scleronomic. Holonomic means the constraints which can be explained in the form of an equation. The example is the motion of a bob of simple pendulum. The next is non-holonomic constraints, means the constraints which cannot be expressed in the form of an equations. The example is the particle placed on the surface of sphere. Next, the rheonomic means time dependent constraints. Example is a pendulum with an extensible string. Next, the scleronomic means the time independent constraints. Okay, scleronomic. The example is a pendulum with an inextensible string. Next, what I discussed, the degrees of freedom. What do you mean by degrees of freedom? The number of independent variables in which the motion of a system is described is called the number of degrees of freedom. Next, space point and configuration space. What do you mean by that? A single particle has 3 coordinate system and the 2 particles has 6 dimensional, and the 3n minus k is called the degrees of freedom. Okay, this I explained in detail in the second class. Now in this class I would explain about the principle of virtual displacement and virtual work. It is visible, no? Now tell me what do you mean by the displacement. What do you mean by the displacement? The displacement is a scalar quantity or vector quantity. It is the vector quantity that refers to how far out of place an object is. It is the object's overall change in position, means whenever there is change in objects, overall that position is known as a displacement. It is basic things. You know about the displacement and the work. Now, what do you mean by the principle of virtual displacement and virtual work? Okay, let us discuss it. Okay, consider a system undergoing a certain displacement in the configuration space. Already you know about the configuration space. That's why I revisioned you people. Configuration space means what? A single particle has 3-dimensional coordinate system and the 2 particles has 6 coordinate system, and the degrees of freedom 3n minus k is called configuration space. So consider a system undergoing a certain displacement. Okay, a certain displacement in which configuration space in such a way that it does not take any time due to system of particles having certain constraints. Such displacement are called virtual displacement. See here students, consider a system undergoing a certain displacement. Okay, system is there and undergoing certain displacement in the configuration space in such a way that it does not take any time due to system of particles having certain constraints. Okay, constraints means the restriction to motion of a system of particle. Okay, the system undergoing certain displacement in the configuration space in such a way that it does not take any time. Okay, system does not take any time due to system of particles having certain constraints. Because having it certain constraints, such displacements are called virtual displacement. Clear or not? See here, consider a system undergoing consider a system undergoing a certain displacement in the configuration space in such a way that it does not take any time. In configuration space, the system does not take any time due to the system of particles having certain constraints. Such displacement are called virtual displacement, as they do not represent actual displacement. Okay, there is no actual displacement because constraint is present. So such displacements are called virtual displacement. Clear? The work done by the force of constraints is zero. Okay, and the work is called virtual work. The work done by the forces of constraints in the virtual displacement, the work done by the forces of the constraint is zero. Then it is called the virtual work. In virtual displacement only the work is zero, then it is virtual work. Okay, clear? Explanations here. Let delta Ri change in position. It means the displacement. It is not a real displacement. It is virtual, means delta Ri. Be the virtual displacement of the ith particle. Virtual displacement of the ith particle of the given system is in equilibrium. The resultant force acting on each particle of the system must be zero. See here, let delta Ri be the actual displacement of the ith particle of the given system is in equilibrium. The resultant force acting on each particle of the system must be zero. That is Fi equal to 0. Capital Fi, force is 0. Therefore, the virtual work for the ith particle must also be 0. That is Fi delta Ri equal to 0. Fi means force, delta Ri is the virtual displacement. Considering all the particles, the virtual work done. Work done means what? Virtual displacement is 0. The displacement is, that is the force, and the displacement is 0. The particle in virtual work done. So in the summation Fi delta Ri equal to 0. Considering this as equation number 1. If the constraints are present, the resultant force Fi acting on the ith particle is made up of two particles. See here, this Fi is made up of two particles of the forces. The applied force Fia, this A is the applied force, and the force of constraint Fi. See, this capital Fi can be made in two particles. One is the applied force and the ith particle of the constraints. So capital Fi equal to applied force, ith particle of the constraint, Fia plus Fi. Okay, then this equation 1 becomes, means substitute the values of Fi. That is, this equation becomes, summation is as it is, summation Fia plus Fi delta Ri equal to 0. Okay, now summation Fi applied force into delta Ri plus summation ith particle of constraint into delta Ri equal to 0. Consider this as equation number 2. Okay, next, but the virtual work done by the force of constraint is 0. What we want? We want the virtual displacement and virtual work. Virtual displacement is, we know that, virtual work now. But the virtual work done by the force of the constraint is 0. Means, force means summation Fi delta Ri equal to 0. That is virtual work done. That is 0. If it holds good for a large number of systems containing of constraints. When it holds good, when it contains a large number of systems of constraints. Okay, take the example of a particle. Consider constrained to move on the surface. Now the direction of the force of constraint is perpendicular to the surface. See here, read it carefully. Take the example of particle constrained to move on a surface. Okay, consider on the surface there is a movement of a particle which is having constraint. Okay, surface. Now the direction of the force of constraint is perpendicular, means consider the surface, there is a movement of the particles, that particles contain the constraint, that constraint is perpendicular to the surface, while the virtual displacement is along the tangent, then the virtual displacement is along the tangent to the surface, that is summation, then applied force summation Fi applied delta Ri equal to 0. Okay, understood? This is an example, but it does not holds good if the frictionless force act in a direction opposite to that of the displacement. Now the equation 2 becomes Fi A delta R equal to 0. This is the condition for equilibrium of a system. Therefore, thus the particles of virtual work states that the virtual work done by the applied forces acting on a system in equilibrium is 0, provided no frictionless force are present. This is about the virtual work done. Okay, virtual displacement and the virtual work. This may be asked in your examination. See here, the definition of virtual work is what? Thus the principle of virtual work states that the virtual work done by the applied force along on a system is equilibrium is 0, means Fia equal to 0. This condition Fia delta R equal to 0, this only is known as the work done provided on a frictionless force are present. Okay, what you in this the derivation is simple derivation is there. Okay, simple. First, what you mean by the virtual displacement? Displacement means what? Consider a system undergoing a certain displacement in a configuration space in such a way that it does not take any time due to system of particles having certain constraints. Such displacements are called virtual displacement, and this can be represented as Fi delta R equal to 0. Summation means many particles are there, so that why summation Fi delta R equal to 0, and the Fi virtual displacement can be summed of applied displacement and ith particle of the constraint. So Fi equal to Fia plus Fi. Substitute these values in Fi and delta Ri. Take Fia plus delta Ri plus Fi delta Ri. Okay, and simple. Next, Fi ith particle of constraint is 0. Okay, this is ith particle of constraints. Next, simply Fi applied particle dealt with respect to the displacement is 0. This is virtual displacement, and that is virtual work done, that is displacement. Virtual displacement and virtual work done, okay, depending on both, means virtual work done is depending on virtual displacement only. Okay, and next class I would discuss it about generalized force. Okay, first read this only, this is enough. Okay, in next class I will explain about the generalized coordinates. So what I explained: first, constraints, types of constraints, degrees of freedom, configuration space, and virtual displacement and virtual work done. Okay, thank you.